This is a video to show you how to work problem number 5 on the moles to mass stoichiometry assignment. So, again, same balanced equation as you used on 3 and 4. You've got 2 hexanes reacting with 17 oxygens to produce 12 carbon dioxides and 10 waters. So to solve this problem, let's go ahead and read it. We should do that first. If I make 13.3 moles of water, how many grams of hexane did I burn? So we're burning hexane. We want to know how much we burned if we end up with 13.3 moles of water. So we know how much water we got at the end, but we don't know how much hexane we burned. So what do we know? Well, to answer that question, let's look for the number. We see that we have 13.3 moles of water. Well, that's what we know. We know we have 13.3 moles of water. At the end of this experiment, they ended up with 13.3 moles of water. And what do they want to know? They want to know how much hexane burned. So how many grams of hexane burned? Okay, so we now know what we know, and we know what we need to know, and that's the information we need to be able to solve a problem. So we're going to take this and we're going to see how to get there, how we should set up our problem. As I've been saying, this question, we're going to use this substance, water, on the right-hand side. So the first question goes on the right-hand side for these. Second question goes on the left-hand side. So we're putting water as a substance on the right-hand side and hexane as a substance on the left-hand side. So we're starting off with the moles of water. That's moles of water over here. This is where we start. And we're going to grams of hexane. So we're going to the mass of hexane. And this should look like every other problem you've done on this assignment, same path. We're going from moles to moles and then moles to mass. And just like every other problem you've worked on this assignment, that's going to need 2 conversion factors. So let's set this problem up knowing that we need 2 conversion factors, and this is our starting number. So our starting number is 13.3 moles of water. We know we need 2 conversion factors. All right, let's see. This first conversion goes from moles of water to moles of hexane. So let's put moles of water on the bottom so the units cancel out, and moles of hexane on top, because that's where we're going to with this first arrow. This is a moles to moles conversion, and just like all the other moles to moles conversions we do, we need the mole ratio, and to get the mole ratio, we look at our balanced chemical equation. So we look for the coefficient that's on water. The coefficient on water is 10, so 10 goes with moles of water. We need the coefficient that goes on hexane to go with the moles of hexane. So we're going to look for hexane up here. It's got a coefficient of 2. So we will put 2 down there. Now occurring to me, that's not hexane. What is that? Oh well, not hexane, my bad. C6H10. For our second conversion factor, we're going from moles to mass. So we put moles of C6H10 on the bottom and mass on top. We put where we started on the bottom so it cancels out, and where we're going to on top. So at the end, we want this unit, what do we want to know, on top up here. Now, anytime we go from moles to mass, we need to look up the molar mass. And the molar mass you can find by looking up the masses of each element on the periodic table. So for C6H10, we need 6 carbons and 10 hydrogens. So we look up the molar mass of carbon. So 6 times the molar mass of carbon is 12.01, gives us 72.06. 10 times the molar mass of hydrogen, which is 1.01, gives us 10.10. We add them up, we get 82.16. So 82.16 goes with grams on top. 1 goes with moles on the bottom. So, let's see what cancels out now. Back up here, we're going to see what cancels out. Well, moles of water cancels out with moles of water. We have moles of C6H10 and moles of C6H10. They both cancel out with each other, and we're left with grams of C6H10. So, we've got 13.3. Let's see, that canceled out times 2, that canceled out, times 82.16 grams of C6H10. In the denominator, we've got 10. That cancels out. Times 1 is still itself, and that cancels out. So we're going to take these numbers, and we're going to put that into our calculator. We're going to take 13.3 times 2 times 82.16 divided by 10. And you should get 218.55. Yes, okay, we're good. Grams of C6H10. Our last step is to check the number of significant figures. So we need, let's see, look at that starting number we were given. 1, 2, 3 sig figs. We should have 3 sig figs in our answer. Starting from the left, we keep this digit. That's our first, second, third. We only get to keep 3 digits. So we need to round to the nearest one. So we're going to round 218.55 up to 219 grams of C6H10. That is your answer for number 5.